Ancient sailors once steered their ships by the stars, trusting those tiny lights in the sky as constant, dependable guides. For millennia, stars have symbolized order, burning according to well-understood rules governed by the forces of gravity and fusion. But what if some stars are lying to us? Across the universe, astronomers have discovered a handful of stars that break the laws of physics as we know them. These stars shine with impossible elements, act far older than they should be, or erupt and recover in ways no theory can explain. They aren't just scientific puzzles, they're cosmic paradoxes. Take Przybylski's star, for example, a seemingly ordinary point of light hiding an impossible chemical fingerprint, or the Methuselah Star, which appears to be older than the universe. And that's just the beginning. These aren't the celebrities of the night sky. You won't hear about them in high school textbooks or on your average stargazing app. These are the rebels, the misfits, the stars that astrophysicists whisper about late at night. Today, we're not talking about the familiar Betelgeuse or Polaris. We're diving into the stars you've never heard of, the ones that shouldn't exist. In 1961, Polish-Australian astronomer Antoni Przybylski discovered a star that looked fairly ordinary through a telescope. It was located in the constellation Centaurus, relatively close on a cosmic scale, just a few hundred light-years away. But when he analysed its light spectrum, something very strange appeared. Stars tell their secrets through light. When split into a spectrum, that light reveals dark lines, unique fingerprints of the elements within the star. Most stars show hydrogen, helium, a touch of carbon or iron. But Przybylski's star, it showed something else entirely. The spectrum revealed the presence of rare Earth elements, and even worse, short-lived radioactive ones like promethium, americium, and possibly even einsteinium. These elements have half-lives of mere days or years. They decay quickly, making their presence in an old star completely baffling. They simply shouldn't be there unless they were somehow recently produced or deposited. This star violates everything we thought we knew about stellar evolution. Stars are fusion engines, not particle accelerators. There's no known process inside a stable star that can naturally create and sustain such heavy, unstable nuclei. To make matters more bizarre, follow-up studies over the decades have confirmed the findings. This wasn't a measurement error. Przybylski's star really does contain elements that should have long since decayed away. So how do we explain it? Some have suggested that these radioactive elements don't come from inside the star at all, but from a shell of material, possibly debris from a neutron star collision, that is orbiting the star and contaminating its spectrum. Others believe the star might contain unknown, ultra-stable isotopes that decay slowly into the ones we detect. And some astronomers, they simply throw up their hands. Przybylski's star is one of the weirdest objects in the sky, and we still don't know why it exists. It's not bright, not photogenic, and not famous, but it's a cosmic riddle that refuses to be solved. When scientists encounter a cosmic mystery like Przybylski's star, they don't just marvel, they hypothesize. Over the years, 4 main theories have emerged in an attempt to explain how a star could contain radioactive elements that should have decayed long ago. None of them are perfect, but each offers a glimpse into the limits of what we currently understand. Let's walk through these 4 leading ideas. Theory 1. A cloud of radioactive debris. One popular theory is that the strange elements aren't actually inside the star, but rather surrounding it. Perhaps a nearby supernova or a neutron star collision ejected radioactive material into space, and Przybylski's star simply passed through the cloud or captured some of it into orbit. That material could then contaminate the star's spectrum, giving the illusion that these elements are within the star itself. Theory 2. Capture from a neutron-star merger. A more exotic scenario involves our process nucleosynthesis, the rapid capture of neutrons in extreme environments like neutron star collisions. These events forge the heaviest elements in the universe. If one occurred nearby and Przybylski star happened to scoop up some of the freshly formed radioactive debris, it could explain the star's bizarre chemical makeup. But again, the odds of such a precise interaction are incredibly low. Theory 3. The island of stability. This is where things get speculative. Nuclear physicists theorize the existence of extremely heavy isotopes that lie on what's called the island of stability, a region of the nuclear chart where elements with very high atomic numbers might have unusually long half-lives. If such isotopes exist and decay slowly into the radioactive elements we observe, that could explain Przybylski star's persistent chemical weirdness. But we haven't confirmed any of these isotopes in laboratories on Earth, let alone in space. Theory 4. Something we don't understand yet. Finally, there's the most humbling possibility. Maybe we simply don't know enough. Our models of nuclear decay and stellar chemistry might be incomplete. Przybylski's star could be pointing to unknown processes, something beyond our current physics. Sometimes it's the strangest stars that shine the brightest light on our ignorance. Przybylski's star may be the strangest of them all, but it's not alone. Scattered across the universe are other stars that break the rules, stars that seem to rewrite what we thought we knew about age, structure, and even time itself. Let's take a closer look at a few of these stellar anomalies. Betelgeuse, the star that refused to die. Betelgeuse, the bright red supergiant in Orion, made headlines in recent years when it dimmed dramatically in late 2019. Astronomers wondered, was this the prelude to a supernova? But then it brightened again, and dimmed, and fluctuated. The explanation turned out to be complex, likely a mix of dust clouds and surface temperature changes, but it shook confidence in our understanding of how massive stars behave in their final stages. Betelgeuse reminded us that even familiar stars can behave in ways that catch us off guard. Blaze star, the one that keeps coming back. Then there's T Coronii Borealis, also known as the Blaze star, a recurring nova. Most stars go nova once, maybe twice, as a result of matter transfer in a binary system. But Blaze star flares up every few decades as though refusing to settle down. It's a stellar zombie, dying, reviving, dying again. Each flare is a signal that we may not fully grasp how thermonuclear reactions unfold in certain binaries. Methuselah Star, older than the universe. Perhaps the most perplexing is HD 140283, better known as the Methuselah Star. When astronomers first calculated its age, it came out at about 14.5 billion years, older than the universe itself. Clearly, something was off. Later measurements adjusted the age slightly downward, but the number still hovers uncomfortably close to the universe's own estimated age of 13.8 billion years. Either our models of stellar aging need revision, or we're missing a crucial piece of cosmic history. Hubble's odd discoveries in the Tarantula Nebula. Deep within the Tarantula Nebula, in the Large Magellanic Cloud, the Hubble Space Telescope has captured stars that seem chemically out of sync with their environment. Some burn far hotter than expected, while others contain metal signatures that don't match any known origin scenario. It's like stumbling upon a group of people in a remote village, all speaking a different language. Clearly out of place, but undeniably real. Stars that defy gravity or something more. A few recent candidates appear to challenge even gravity. Stars that spin at near breakup speed or move through the galaxy faster than escape velocity allows. Some theories suggest they've been flung from galactic centers by supermassive black holes. Others flirt with more exotic possibilities, like interactions with dark matter or even dark energy. One hypothesis suggests such stars might be affected by as yet undiscovered forces that slightly warp the space around them, altering how we measure their motion and composition. These stars aren't just scientific curiosities. Each one acts like a red flag, a signal that somewhere something about our cosmic playbook might be wrong or incomplete. It's easy to look at these strange stars as isolated oddities, freaks of cosmic nature. But in science, anomalies are often the cracks through which the light of discovery shines. Each of these stars challenges a specific part of our understanding. Przybylski's star confronts nuclear physics. Methuselah Star calls into question our age estimates for the universe. Blaze Star throws our models of stellar death and rebirth into chaos. And the mysterious stars in the Tarantula Nebula hint at chemical processes or galactic histories we've yet to uncover. If even one of these stars exposes a flaw in our models, it could trigger a cascade of discoveries. That's how science advances, not by confirming what we already know, but by grappling with what we don't. More than that, these stars remind us that the universe isn't a solved puzzle. It's an evolving mystery, filled with surprises that keep pushing the boundaries of what we think is possible. Every unexplained spectrum, every misbehaving nova, every contradictory age reading is an invitation to look deeper, to think differently, to explore further. In a way, these stars aren't breaking the rules. They're revealing that the rules may never have been complete to begin with. The good news is, we're just getting started. New tools like the James Webb Space Telescope, JWST, and the upcoming Extremely Large Telescope, ELT, promise unprecedented views into the chemical makeup and behavior of stars across the cosmos. These instruments allow astronomers to peer deeper into stellar atmospheres, detect fainter spectral lines, and observe objects further away and older than ever before. Future spectroscopic studies could help confirm or refute the presence of forbidden elements in stars like Przybylski's. They might also reveal entirely new classes of stars we haven't yet identified. With machine learning and AI now assisting in data analysis, we're better equipped than ever to spot anomalies we might have missed before. Meanwhile, advances in nuclear physics may finally uncover whether theoretical isotopes like those in the island of stability actually exist. If they do, they could explain not just one strange star, but a whole family of seemingly impossible objects. What's most exciting is this. For every mystery we solve, new ones are likely to appear. That's the beauty of astronomy. It's not about finding final answers, but asking better questions. The stars that shouldn't exist might just lead us to truths we never expected. In the grand story of the universe, stars have always been our narrators, telling us where we came from, how matter formed, and what lies ahead. But every so often, a few stars start speaking in riddles. These are the stars that shouldn't exist. The ones that glow with forbidden elements, that seem older than time, that challenge everything we thought we knew. They're not famous. You won't find them on posters or in a science fiction blockbusters, but perhaps that's what makes them so important. Because sometimes the stars we've never heard of are the ones trying to tell us the most.